There is a reason for all these names, but we don't have time to go into the reasons behind them.
That'd be a tangent.
That's 1 over tangent. Yes, that would be thank you, Cody. We're not going to go off on that tangent right now. Cotangent is 1 over tangent, so this is adjacent over opposite. Very good. Now, just like the sine always has to be between 0 and 1, that's not an equal sign I want there, the cosecant of theta always has to be greater than 1. Okay? The secant of theta also has to be greater than 1. Why? Because the cosine has to be less than 1. Yes, Emma? Cotangent. Yes, cotangent. There's a reason for all these names, and we'll discuss this throughout the week. And the cotangent, since it's reciprocal of something that can be any number, it can also be any number. Your calculator does not have a cosecant, secant, or cotangent button on it. So you've got to use the sine, cosine, and tangent buttons and find the reciprocal yourself. Yes?
But it does have sine -1.
Great point. Okay, wasn't going to go over that yet, but Amy's observant. Okay, you know how I said I hate the -1 in the exponent spot because sometimes it means inverse and sometimes it means reciprocal? On your calculator and in math notation, sine -1 theta is not the same thing as sine theta to the -1. This means inverse, and this means reciprocal. In other words, this notation, if I put the sine inside parentheses, put a -1 on the outside, that would mean reciprocal of sine. And I just told you that that means cosecant. This button on your calculator and this notation with the -1 right here has nothing to do with exponents, nothing to do with negative exponents, nothing to do with reciprocals, and means inverse. We'll go into this in more detail later. The short thing is for tonight's homework, stay away from that button.
Okay.
All right. The slightly longer explanation, which we'll go into more detail, is if you hit the sine button on your calculator, you give your calculator an angle, and it gives you a ratio of opposite over hypotenuse. Okay? If you hit your the inverse sine button, the calculator expects you to give it a ratio, and it will tell you the angle that caused that ratio. But it has nothing to do with cosecant, unfortunately. But thank you for noticing that. That's actually important. So the calculator can't help you find cosecant, secant, and cotangent directly. All right? Now I'm going to erase this part and practice a little bit. Okay, without a calculator. Without a calculator.
People do math without calculators so often.
Find all 6 trig ratios of theta. And here's what I'm going to tell you. Okay, it's a right triangle. If it's not a right triangle, none of this applies. The hypotenuse is 13. The adjacent is 12.
And then 15.
And this angle is theta. What's the other side?
5.
Excellent. Okay. This side is 5. I didn't tell you it was 5. Amy and Karen knew it was 5. How'd you guys know it?
Because it's one of the
Pythagorean triples. It's a Pythagorean triples. The first one is 3, 4, 5. The next one is 5, 12, 13. There are more. Any multiples of them also work. If you don't remember that, then you would have to set up a squared plus b squared equals c squared, and you'd have to solve it for the a squared. Okay? Yes, Eli?
Yeah, there's a blind girl who went to the proof for the Pythagorean theorem.
I read something about that. I mean, it wasn't the first proof, obviously, but yeah.
Like Albert Einstein made a proof when he was 12, and
Yeah.
and Garfield Carson, he made up a proof when he was little too.
Yeah, there's more proofs of the Pythagorean theorem than like anything else. It was back in the day. It was a way to prove you were smart. Like some people quoted poetry, some people memorized pi, other people would just prove the Pythagorean theorem before they hit like 20. I didn't do one of those. I accepted all the proofs that were handed to me. Okay, if you were just given two sides, use the Pythagorean theorem or your vast knowledge of Pythagorean triples to figure out the third side. And from here, can you tell me all 6 ratios of theta? The sine of theta will be what?
We don't want to tell you.
5 over 13. Oh, come on, share. Cosine of theta will be?
12 over 13.
12 over 13. I'm just doing the opposite over hypotenuse, the adjacent over the hypotenuse. The tangent of theta?
5 over 12.
5 over 12. What will the cosecant of theta be?
5 over 13. Well,
Exactly
the
wrong.
13 over
Not the
5.
opposite. The opposite would be negative 5 13ths. Not the inverse.
13 over 5.
13 over 5, yes. Thank you, James, for proving my point about the 3 most confused words in math. The secant of theta will be
13 over 12.
13 over 12. And the cotangent?
12 over 5.
12 over 5. Okay.
We've proven them. Can we go home now?
You haven't proven them. You've demonstrated them. Okay, just a couple quick notes. This is less than 1, like it should be. This is less than 1. The numerator is less than the denominator, so it's less than 1. Tangent can be anything. This has to be greater than 1 check. This has to be greater than 1 check. Cotangent can be anything. Okay, that part of the pattern will always work. A couple of these will involve some messier numbers. Okay, they'll be if what you're given is not part of the Pythagorean triple, then the numbers are going to be ugly. I'm going to do one of those because if I say to do it without a calculator, who thinks they know what problem you're going to run into? No calculator, and you're doing the Pythagorean theorem. What happens?
Really big numbers.
Not really big numbers.
You gotta know your squares.
You got to know your square roots. You got to simplify your radicals. Good. So I'm going to make one up, and the numbers will be intentionally ugly.
Because he hates us.
Exactly.
You hate us?
You guys figured it out. That looks like an isosceles triangle, but it's not going to be one. I'm just going to say this is...
Well, it might be, but they're still right angle.
Right. I'm going to say this is 10, and this is 7. Okay? So what's my remaining side? What's the side you have to figure out?
The other one.
How are we going to figure this out?
Pythagorean theorem.
Pythagorean theorem.
49 plus something equals...
A squared plus 7 squared.
149.
What's the square root of 51?
I don't know.
No, never.
You're way ahead of me, though. It's 10 squared. No, I think you're right, because it is going to be a squared plus 49.
51.
Yeah, equals 100.
7 point something.
A squared is 51. A is root 51. It's 7 point something, but if I say to do this without a calculator, then you leave it as the square root of 51. Now, I didn't do this on purpose, but square root of 51 actually only breaks down to 3 times 17 that I can think of. And can I simplify that radical at all?
No.
No.
3 times the square root of 17.
Well, no, I can't pull the 3 out, so there's only one of them. It would have to be 9 times 17 to do that. Since neither of these are square roots, and beyond that they're both prime, I'm actually stuck with it in this form. I was thinking, should have come up, never mind. Okay, so this is
You should have been nicer to us.
the square root of 51. Okay, so what is, I'll put theta here. Actually, this time, what I'm going to do? I'm going to put theta up here. Theta's going to be that angle instead.
Nicer.
That's, so what does that make the sine of theta?
7 over 2.
Square root of 51.
Nope, now square root of 51 is the one opposite the angle, so it's square root of 51 over 10. Layla correctly figures the square root of 51 is 7 point something, so this is still less than 1. Cosine of theta will now be, what's that going to be?
7 over 10.
7 over 10, because now this upright side